client, to populate the Twitter page with data, is going to make requests to our Express server. That Express server is going to hand over that request to GraphQL. GraphQL is then going to perform that request on our database, and then return the results all the way back to our client, our browser. Now you might be asking yourself, why not just use a REST API? Why GraphQL? Well, there's a multitude of reasons. I'm going to put it in the most simple terms. GraphQL makes queries a lot more efficient than REST and is a lot more dynamic. The problem with REST is its rigid server endpoints, which can make your server code extremely complex. What do I mean by this? Well, every URL specifies a resource, a certain UI, which relies on a piece of data. You need a URL endpoint to request that data. However, the more URL endpoints you add, the more API calls you end up making, which can cause network traffic and render your app slow. The main problem, however, is how complex and messy your code can get. REST has no versioning mechanism. Every time you refactor your code, you have to be aware that there are still old clients that require endpoints in the old format. You're going to end up having to leave that old code and create endpoints on top of them. How is GraphQL better? All the data for any given UI can be sent from GraphQL in a single request. It is much more flexible and dynamic than the rigid REST API, which requires a URL for every resource. GraphQL makes our server a lot more responsive to the needs of our clients. It is the modern approach to backend development, and will make your life as a backend developer much easier in the long run. Welcome back to another video. Before we start getting into setting up the GraphQL server, you first need to set up your developing environment. If you already have a code editor installed onto your machine, whether it's Visual Studio or Atom, feel free to skip this video and move on to the next one. Otherwise, make sure to follow along with this tutorial by first going to this website, code.visualstudio.com. And we're going to click on this download icon right here. If you're using a Mac, make sure to download Visual Studio for Mac. Otherwise, choose Windows. I personally have a Mac, so I'm going to choose this link. And once you finish downloading Visual Studio Code, make sure to extract it from its compressed zip file. I already have it installed, so I'm going to cancel this download. If you have any problems with the rest of the installation, it should be very simple, but if you do, feel free to ask me in the Q&A section. In this video, we're going to install Node.js. If you already have Node.js installed, feel free to skip this video and move on to the next one. If you've never used Node.js before, it is an open source runtime environment which runs JavaScript code on a server. Many of the tools and modules you're going to use to build your server will require Node.js, so it's very essential that you install it. In fact, if you're ever building a web server, most likely you'll always need Node.js as it makes up one of the 4 components of the main stack. Anyway, inside of nodejs.org, go to the Downloads tab. And since I'm using a Mac, I'm going to download the Macintosh installer. Once it's done downloading, I'm going to open the package. And now all you have to do is just keep pressing continue, agree to the terms and conditions until you finish installing it. I've already done all of this, so I'm not going to reinstall Node.js, so feel free to ask me in the Q&A section if you have any trouble finishing up the installation. Alright, I'm assuming by now you've finished installing Node.js. If you're using a Mac, go to your terminal. If you're using a PC, you would go to your command prompt. I believe that's what it's called. And if you type node-v, you'll see the version of Node we installed. So right here, you know that you've successfully installed Node. Now write npm-v to see the npm version. npm is the Node package manager. This Node package manager is used to install various dependencies and frameworks onto our project, our server. We're going to be using npm very often, so make sure that an npm version shows up when you type this command. And that is it for this video. In the next one, we're going to start setting up our server. I'll see you then. In this video, we're going to set up a simple Express web server which uses GraphQL. We will start by installing and using the Express library to set up a server that listens to any connections that occur on a given path. To start this off, go to your terminal and navigate to your desktop directory by writing cd desktop. CD standing for change directory. Now write mkdir to make a new directory called GraphQL tutorial. Once you press enter, clearly this command creates a new folder in which we are going to install the Express library. Navigate to your project folder by writing cd, your project name, GraphQL tutorial, and notice the autocomplete when you press the tab button, which should be on the top left of your keyboard. Press enter. And now inside of your projects directory, write npm init to initialize the node package manager onto your project. And now feel free to just keep pressing enter since we're only developing tutorial apps at the moment. We don't really care about authors, licenses, and all that other stuff right now. It's not very important to us. And if you press enter again, we've successfully initialized our node package manager. To prove that, open up your project with Visual Studio by clicking on a new window. Click on the top left icon, press on Open Folder, and go to the project folder that we just created in our desktop. Press Open. And inside of this project, you should notice a package.json file which showed up as soon as we initialized npm into our project. Whenever we install a dependency, it's going to show up in this package.json. So let's install Express. In your terminal, write the command npm install --save Express. And now the Express dependency is being installed onto our project. Notice that it now shows up into our package.json file, which indicates a successful installation. And we also get our node modules folder, which contains modules that we can import and use in our project. One of these being Express, which is what we're going to import at the moment. Before we do that, I need to point something out, and that is that GraphQL and Apollo with Express is documented with ES6 import and export syntax, which is exactly what we're going to do for our project as well. So create a new file called server.js. Server.js is where we are going to initialize our Express web server. And the first step to doing so is to actually import Express onto our project by writing import Express from Express. This line of code, what it does is that it imports the Express framework that we just downloaded. It loads the module such that we can use it with this variable. However, what would happen if I ran this block of code? To run this code, first make sure to save everything in your project by going on File, Save All, and now into your terminal. Make sure you are in your projects directory. I already am. If you're not, make sure you cd into it like we did before, and write node to run the file server.js. Server.js. This gives us an error. And the reason is this ES6 import syntax is not currently supported by Node.js. We need to use an alternative JavaScript compiler to compile this ES6 syntax. This compiler is called Babel. To install Babel, in the Babel website, make sure to go into it babeljs.io. According to this, all we have to do is first install these Babel development dependencies. To do that, just copy and paste this command right into your terminal like so. And once you've finished installing the dependencies given to us by the Babel website, they should show up in this package.json file. And there is one more step we have to do that was instructed by the website, which was to create a .babelrc file. So let's do just that, new file, .babelrc. And now we just have to copy and paste this JSON that was also given to us. like so. Now that we set up Babel into our project by following the steps given to us by the Babel documentation, there is one final step, and that is we need a way to tell Babel to compile this code so that we can use the Express framework and avoid the error that was given to us since Node doesn't support this ES6 syntax. To do that, in your package.json, we're going to make a script. I'll explain what I'm doing in just a second, but for now, make a script with key build and a value Babel node server.js. Basically, whenever we run the script that's named build, this value gets triggered. What this value does is that it compiles the server.js file, this file right here, with Babel, such that it's compatible with Node. So it will run this ES6 import statement that we were not able to run before. How do we run the script? Well, that's simple. First, make sure to save all of your files by going on File and Save All. And in your terminal, run the script by writing npm run and whatever your script key is, in this case, build. And by calling this, it will trigger this value right here, which is going to run our server.js file with Babel. So press enter. And notice that we do not get any errors. Our server.js file ran perfectly with ES6 syntax. We've successfully just imported the Express module with Babel. Now I did promise that we would set up our web server in this video, but it has gone on long enough and I want to keep this video short, so let's take a break and we'll continue in the next video. One of the most popular and easier ways to initialize a web server is with Express, and that is what we're going to do in this video. If you're familiar with Express, you've probably done this many times before, so I recommend that you simply download the finished project that's in the resources folder and move on to the next video. If you're not familiar with Express, best follow along with this tutorial. In the last video, we were able to successfully import the Express module using ES6 syntax. Now this dependency that we're importing, what are we getting from it? What is it giving us? Well, if you go to the Node modules folder, where Express was installed, and if you scroll down to the Express folder itself, go down to index.js, you'll see what's being exported from the Express module. What's being given to us are the contents of the Express file that's in the lib folder. So go to lib and express.js, which is just this path that's being exported by Express. You'll see that it's exporting a function called createApplication. So if I go back to server.js, and just set a variable equal to an instance of Express by writing const server is equal to Express, then I'm actually setting this constant server equal to the return value of this function, app. And this return value, app, has many properties and methods that we can now access through this constant server, which is perfect because one of the methods that we're going to use to start up our server is the listen method, which we now have access to. So write server.listen. The listen method, when called, runs an HTTP server which listens to any connections that occur on a given port. The port that the server is going to listen on for connections is port 4000. The second argument will be a callback function that gets triggered as soon as our server starts listening for connections on this port. So we're going to put in an arrow function that triggers a console.log statement. Console.log listening on port 4000. Let's now run this code on the terminal by saving all the files first by going on File, Save All, and running our script. So go to your terminal, navigate to your project's directory by writing cd desktop / your project name minus GraphQL tutorial, and now run the script that we made before npm run build. And notice this console.log statement. It got triggered, which means that the server is actually listening on port 4000 without any errors. We can access this port through our browser by going on to Google Chrome and writing localhost 4000. That's the port that we're listening on. And it's on this URL that a user is going to make requests to our server. Since the user is making requests on port 4000, our server is going to listen for these requests and trigger a response. We haven't added any response logic yet. We'll do that in the near future. We get this result of cannot get because no GET requests were made to our Express server to modify this page in any way. Let's do just that. In your project, write server.get with your first parameter just being a path of, let's say, /GraphQL. So the idea is that if I go to my browser and I write, let's say, localhost 4000 /GraphQL, it should trigger this GET request right here in which we want our server to send back a response. We'll do that with a callback function upon getting this GET request. So put an arrow function with parameters rec and res. Rec stands for request and res response. We want to send back a response to the browser that made this request. So write res.send. And we're going to send it HTML code to modify its interface. To write HTML code in a JavaScript file, first wrap it in a string quote, and all HTML code needs to be enclosed by HTML tags. So put an opening HTML tag and a closing HTML tag. And we want to modify this page so that the body has a title of Hello World. So let's put in an opening head tag and a closing head tag. Think of the head tag as just a container for metadata. We don't care about the metadata of this page right now, just the body. So declare the body tags as well. Opening body tag, closing body tag. And inside of the body tag, we want a header, a big title to show up. This is done inside the h1 tags. Opening h1, closing h1. And we want our title, our header, to say Hello World. So just put Hello World inside of the h1 tags. If you're not familiar with HTML, we're barely ever going to write HTML code. The only thing I want you to take away from this is that once you go to the path /GraphQL, it's going to make a GET request, which the server is going to process, the Express server, and it's going to send back a response in the form of HTML code to give this page a title of Hello World. So save your file, and if I just rerun the app, if I go to the path /GraphQL, we get Hello World. Now, what if I put no path? If I save the file, rerun the app, if I go back to this, nothing happens on the path GraphQL because the path is specified to be empty. So if I simply go to localhost, there you go. This was just to show you how Express works and how it manages requests. We don't really care about this HTML code, so I'm just going to delete it. We still have one more boilerplate task to finish up before we start digging deeper into the course content, and that is to set up Babel Watch. We'll do that in the next video. In this video, we're going to set up Babel Watch. Right now, every time we make changes to our project, we have to save everything and rerun our script, which can be a problem. For example, if I add another console.log statement right here, changing the file, I have to resave the project, go to my terminal, and rerun our script, npm run build. And there you go, our console.log statement gets triggered, changing the file. Now, what if we only had to run this script once, and every time we saved changes to the project, the script would run automatically on its own? To accomplish that, we need Babel watch. So I'm just going to cancel this command by pressing on Option C. Hey, it's Rand from the future. I may have said to use the command Option C to cancel a command. It's actually Control C. And that is all. Feel free to move on with this video. And I'm going to install the dependency Babel watch. npm install -- save Babel watch. Once Babel watch is installed, it should show up in your package.json. Now, instead of Babel node, write Babel watch. And so our server.js file is still going to be run with Babel, except now Babel is going to watch for any saved changes that occur to our server.js file and automatically rerun the code on its own. If you've ever used NodeMon before, this is the exact same concept. So I'm just going to save the changes to my package.json. I'm going to rerun our script, npm run build. And now it's watching for changes in our server.js file. To prove that, if I go to server.js, let me just put the terminal and project side by side. If I change this file by, let's say, changing the console.log statement to changing the file with an exclamation mark, if I save this file, Babel watch detects the changes and the code is automatically rerun with the new log statement showing up. This will save us a lot of time in development. And now in the next section, we can finally start getting into GraphQL. Before going into any code, let's talk about how we're going to approach setting up our GraphQL Express server. The first step, which we already did in the last section, was to set up our Express web server. In general, here is what Express does. The Express server is going to listen for any HTTP requests that are done through the browser on port 4000. Whenever a request is made from the browser, Express listens to it, processes the request, and responds. We already saw this in the Express tutorial when the browser made a GET request, which Express processed and sent back a response of a Hello World title. Now in this section, we're going to get GraphQL and Express to work together. Now what does GraphQL even do? Well, GraphQL, in simple terms, makes it easier and more efficient to perform queries or mutations on a database. In our case, assume that a user went into the browser such that he made a request to query something that's inside of our database. The query request goes to Express. Express is going to hand over that request to GraphQL, which is then going to perform that query on a database. And once it does that, GraphQL is going to send back a response to Express, and Express sends that response back to the browser, giving the client, the browser, the data that was requested by the query. So just know that GraphQL is only a small component of our app. It simply makes queries and mutations more efficient, and also has some other great features like real-time subscriptions, which we're going to implement later on in this course to build our Twitter application. However, how do GraphQL and Express know how to work together? This is done through a package called Apollo Server Express. Apollo Server Express is going to serve as a compatibility layer between Express and GraphQL. It's what we need to get GraphQL and Express to work together. Naturally, they do not know how to work together. They're two separate libraries. Apollo Server Express, in a way, is going to bind the two. It's going to be the glue layer. We'll start implementing that in the next video. In the last section, we finished setting up our Express server. In this section, we're going to get our Express server and GraphQL to work together. We saw how Express was able to handle requests and send back a response in the form of HTML. Now, instead of having Express directly handle requests made by the client, we want Express to hand over that request to GraphQL and let GraphQL take care of it. Once GraphQL has done its job, it's going to send back a response to Express, and Express will in turn send it back to the user. In your terminal, navigate to your project's directory. Mine is in the directory desktop, and my project name is GraphQL tutorial. Once you are in your projects directory, write npm install --save. And the dependencies that we want to install are GraphQL, as well as Apollo -server -express. Apollo server express. Obviously, we need to install GraphQL to be able to use the GraphQL library. It has all of the GraphQL tools that we need to set up our application. And Apollo server express, as discussed in the overview, is going to act as a glue layer between GraphQL and Express. Naturally, GraphQL and Express don't really know how to work together. They are two completely separate libraries. Apollo Server Express will act as the glue layer between the two. It's going to get them to work together. So install your dependencies. And once you have them all installed back into your server.js file, we need to inherit two properties from the Apollo Server Express library that we just installed. To do so, write import, put a set of curly braces from Apollo Server Express. So the Apollo Server Express library, it exports two properties that we need to access. We can access them here inside the curly braces as properties of an object. The two properties being exported by Apollo Server that we need to access are GraphQL Express as well as Graphical Express. It's very important that you get these names right to properly reference the properties being exported by this library. It doesn't matter what order you put them in as long as the naming is correct. So now it's time to set up Graphical. Graphical is a development tool. It's a query editor made by the Graphical team that allows you to perform queries on our GraphQL server. It's only intended for development purposes. And so why would we use this Graphical tool? Let's just assume that right now we had a data store or some kind of database which contained some information or data. Normally, to query or modify anything in our database, you would have a React Apollo client, which would send a request to the Express server to either query or mutate data that's inside of the database. The Express server then is going to hand over the request to GraphQL, which then is going to use a resolve function. We'll go into that later. It's going to use a resolve function to perform the query or mutation. For now, we just want to focus on how GraphQL works. We don't want to set up an Apollo React client just to see how mutations and queries work. That would take a lot of time to do, and that is exactly why the GraphQL team made the development tool Graphical. And for now, it's what we're going to use. We will link GraphQL to React later on to build our real-time Twitter application. But for now, we just want to see how GraphQL queries work. So we'll use this temporary client and query editor, Graphical. So how do we set up this Graphical tool? Well, if I go to my browser for just a second, we need to tell the Express server whenever a connection is made to the route/Graphical. So whenever we actually write localhost 4000/Graphical, we want the Graphical tool to show up on this path. We want to use the Graphical tool on this path. To do this, inside of server.js, write server.use. We want to use Graphical on that path. So first of all, specify that path as /Graphical. And on this path, we want to use the Graphical Express middleware. So just declare it as the second argument, and we should be good to go. If I save all of my files and actually run a build or run our script, npm run build, what I would expect is if I go to localhost 4000/Graphical, our Graphical tool should show. So let's test this out. Localhost 4000/Graphical. And we get an error, cannot read property endpoint URL of undefined. It's telling us that in Graphical Express, we need to declare an option endpoint URL. Options are normally declared inside of curly braces, so let's just declare the option endpoint URL for now as an empty string. So what is this endpoint URL? Why do we need it? Well, think about it. We need Graphical to send requests to Express. It's going to send that request to a certain path in which Express is going to listen to. The path to which the request will be sent to Express is the endpoint URL. And we're going to specify this endpoint URL as /GraphQL. So the idea is that we want Express to listen to any connections or requests that are made to this path /GraphQL. So we're going to have GraphQL actually send requests to Express on the path /GraphQL. Express is going to listen for any connections that occur on this path. And once it does, we want it to hand over that request to GraphQL and fulfill the cycle. Okay, so for now, let's save the file and see if we satisfied the error. So if I just press on save, it should rerun. It just did. And if I go to Google Chrome and try this again, all right, the graphical tool finally shows up. This is the development tool that we're going to use to see how GraphQL queries and mutations work. So basically, whatever requests that we end up performing in this tool graphical, it's going to go to the Express route /GraphQL. Express is going to listen for any requests that occur on this route, and we want it to hand over that request to GraphQL. However, right now, we haven't even declared the GraphQL route yet. So back to server.js, let me just close this up and minimize this. So let's actually declare this route by writing server.use, and on the path /GraphQL, any requests that occur on this path, we want to hand it over to GraphQL Express. So just pass in GraphQL Express as a middleware as well. And we should be good to go. Any requests made by GraphQL will now be listened to on this path by the Express server, and the Express server is then going to hand over that request to query or mutate to GraphQL, which is going to take care of that request accordingly. So let's rerun the server to see what happens. File save all. Our Babel watch should rerun our server. It just did. If I go to Google Chrome, try this again, and we get an error. Did you forget to use body parser middleware? So body parser is middleware that can be used to parse JSON. Whatever query or mutation that we end up performing in this graphical tool, which I'll show you how to do later on in this section, it's going to be in JSON format. That JSON query or mutation, as soon as it makes a request to the Express server on this endpoint, before it gets handed over to GraphQL Express, that JSON needs to be parsed. How is it going to be parsed? Well, we're going to use the body parser dependency to do that. So back into your terminal, I'm going to cancel this command by pressing on Option C. And to install body parser, write npm install --save body parser. Once you've finished installing it, import body parser into your project by writing import body parser from body parser. All right. And the idea is that before the request to query or mutate is handed over to GraphQL, it needs to be intercepted by body parser. To do that, all we have to do is declare body parser as a middleware by writing body parser.json. So it's going to parse the JSON before it goes to GraphQL. Save your file by pressing on Command S. Actually, let's save all of the files since we just installed a new dependency in our package.json. And if I go to the localhost 4000 right now, the site cannot be reached because I did not actually run the build. So npm run build. Babel watch is working just fine. Let's try this again. Back to Google Chrome. And we get another error. Wow, this is very cumbersome. The error is must provide a schema. Well, you should have expected this. Why do we need a schema? Well, think about what GraphQL does. It performs queries or mutations on a database as requested by the client, GraphQL. However, GraphQL doesn't just magically know what's inside of a database. It doesn't know how to piece that information out and how to access it, or even how to resolve it. We have to tell GraphQL about how all the data is stored, how it's arranged, and very specifically tell GraphQL how to work with that data and how to send back a response. That's what we need a schema for. It's basically a specific set of instructions that we need to specify to get everything in working order. Do note that we don't actually have a database just yet. We're slowly building up towards making one. But anyway, to make this clearer, suppose that this is how data is stored in our application. We have an author, and each author has an age, name, and a set of books. And we want to query all of the authors in our database that have an age of 50. That query would be sent by GraphQL to Express through the express route /GraphQL, where it's then going to be passed over to GraphQL, and with the help of its schema, which we haven't actually implemented yet, is going to know how to access that information and resolve it. We'll implement schemas in the next video. In the last video, we got as far as setting up GraphQL. However, we concluded that GraphQL is not going to know what to do with a request unless we give it a schema to follow. In this video, we're going to create our first schema. First off, we need to install the package GraphQL Tools. GraphQL Tools contains a property that we need to create an executable schema. So in your terminal, navigate to your projects directory. Mine is inside of desktop, and my project name is GraphQL Tutorial. And inside of your project, we're going to install the dependency GraphQL Tools. And once you are done installing it into your project, create a new file called schema.js. This is the file where we are going to create our schema and export it back to our server.js file so that we can use it in this GraphQL Express middleware. So back to our file, we're going to make our schema by using the GraphQL schema definition language. Every schema needs a type definition to instruct it about what type of data we have in our application. The main components of the schema definition language are the type and the fields. For example, imagine a person. That person has a name, age, and gender. So for the type person, you would have fields of age, gender, or let's do name and gender. Ages are normally integers, names are normally strings, genders are strings as well. So that's all it is. There is a type, and each type has fields. Now, schema types normally are specified as strings. So what we're going to do is create a constant type definitions. It's where we are going to specify all the types we have in our database is equal to a string type, an ES6 template literal string. So make sure it's a backtick, not a single quote that you would normally use for a string, but a backtick. The backtick should be located right beside the number 1 on your keyboard. And now inside of these quotes, we're going to place our type of person, like so. And now generating our schema is very simple. To make our schema, we need a property from the GraphQL Tools library. So we're going to import it from GraphQL Tools. And this property is called makeExecutable_schema. And so generating our schema is very simple. Just write const schema is equal to makeExecutable_schema. And the argument that goes into it are the type definitions that we just created. So the type definitions specify what types exist in our schema, whereas makeExecutable_schema generates a schema that tells the server how to execute queries against this type. We're going to tell the server that our data store has persons, and each person has an age, name, and gender. That is how data in our data store is going to be arranged. That's what we're telling our GraphQL server. Okay, now here's a challenge. What if I had a type of author? Try and figure out some potential fields that this author type would have. Pause the video and give it a try. So what I came up with was simply age again. Name, string, authors have ages and names, and let's just say that each author has published a set of books. And books is simply going to be an array of strings, since every author is going to have many books. Okay, so now we're specifying that this is how information in our data store is modeled. We don't have a data store just yet. For now, let's create a fake one. We can do so by first inheriting the property add mock functions to schema. And now, right here in our file, we can create a fake data store by writing add mock functions to schema. And the schema to which we're going to add a fake data store to is schema. By doing this, we get a fake data store according to our type definition. So assume GraphQL requests to query all the authors in our data store. Express would get that request, hand it over to GraphQL, and it would grab a bunch of authors with fake names like Hello World, fake ages like 51, or something. Hence the word mock. All the info is going to be fake, and it's going to be made according to our type definition. And now let's just assume that we assign this schema to our GraphQL Express middleware. We wouldn't be able to perform any queries just yet, and that is because we need to specify a query type. In the type definition, write type query, open up curly braces to specify the fields, and the fields for this query type represent what kind of queries the user is allowed to make. If I write the following field, author, with an array type of author. What this would do is, if inside of GraphQL we call this query field author, GraphQL is going to return every single author that's inside of the fake database. Hence the array, a collection of authors. Now we just need to export the schema so that we can set it as an option for GraphQL Express. To do so, simply write export default schema. And now we can access this schema variable by going inside of server.js and import schema from the file to which we're accessing the schema is schema.js. To access the file, write ./schema.js, the file name. Basically what we're saying is go to the schema.js file and give me back whatever is being exported, so the schema itself. And now just set the schema as an option for GraphQL Express. So just place your schema right here and you should be good to go. Save all of your files. Go to your terminal and we're going to run our build by writing npm run build to see if everything works out. We seem to not have any errors, which is good. So if I go to GraphQL by going on localhost 4000/GraphQL, I'm going to first start by putting curly braces. This is just JSON format that we're writing in. Don't worry too much about it. You'll get used to it as we go along with the course. And inside of these curly braces, we're going to call the query that we created inside of the type definition and assigned to our schema. To call this query, simply write author. Notice the autocomplete that just occurred. GraphQL recognizes that the GraphQL schema has a query type of authors. And so now GraphQL is actually able to make query requests. Add another set of curly braces, and inside of these curly braces we can tell GraphQL what author fields that we want to fetch. And I want all of their names, age, and books. Now, what do you expect would happen if I tried to perform this query? Press run, and we get fake data. Now, this is not very interesting. We want to query real data from a real data store. We'll work on that in the next couple of videos. In the last video, we set up our GraphQL server such that query requests are made from GraphQL through the express route /GraphQL. That request is then handed over to the GraphQL Express library, which performs a query against its schema and gives back the list of fake authors that are present inside of our fake data store. Giving back fake data is not very interesting. Let's do some real queries. delete the add mock functions to schema line. We're going to add some real data. So create a new file called resolvers.js. For now, we're just going to store our list of authors inside of an array. Normally, they would be stored inside of a database like MongoDB. Instead, though, we're going to work with some hard-coded data just to see how resolvers work and how they can be used. To do so, create an array type const authors is equal to an array of authors such that each one has a name, an age, and a set of books. Let's give this first one a name of J.K. Rowling. J.K. Rowling, I believe, is about 50 years old. Forgot my comma right here. And some of the books she's published, obviously, Harry Potter and the Goblet of Fire, as well as Harry Potter and the Prisoner of Azkaban. Let's declare another author by simply copying and pasting this first. And this second author is going to be George R.R. Oh, I seem to have made an error. We forgot our colon right here and our comma. And so the second author is going to be called George R.R. Martin. I believe George is about 70 years old. I'm not too sure. And obviously he wrote Game of Thrones. Game of Thrones. We forgot our comma again, as well as our colon. Game of Thrones, Song of Ice and Fire. And Game of Thrones, A Dance with Dragons. All right, notice that the way in which we formatted this array is exactly the same as what we have in the type definitions in our schema. This is very important as type definitions specify that this is how information in the data store is modeled. And this is exactly how information in our data store is modeled. This is our data store at the moment. It's just a static array, and every author has a name, age, and books. And therefore, your type definitions should reflect just that, which in this case, it does. Because imagine that we added an extra argument of gender right here, of type string. We're giving the user the option to query the author's gender in GraphQL, but we don't have any gender data in our data store. So if we actually try to query the author's gender inside of GraphQL, it would return null and your app would become inconsistent. So always make sure the type definitions specify exactly what you have in the data store. So let's delete this gender field. We don't actually need it. And to actually perform queries on this data store, we need resolvers. Think of the schema as something that just tells us how the data looks like, how the data in the data store is modeled. Resolvers are what actually go into your data store or database and grab that data that was requested by the client, or in this case, the query editor GraphQL. Whenever GraphQL calls the query author, we want to give back every single author that's inside of this data store. We need a resolver to fetch all the author. So to do that, first I will place my semicolon right here and call const resolvers is equal to an object type. And this is going to follow the same format as what we had in the schema type definitions. We will have a type of query, and this type is going to have fields. One of the fields is the query that we want to actually perform, and that query we defined in the type definitions. So make sure to reference that query right here, and that query is going to be followed by an arrow function, which takes in no arguments, and we want to return all of the authors inside of the data store. So when this query gets called inside of GraphQL, it's going to be passed into the resolvers, which is going to grab every single author in this array and give it back to our client. And to accomplish this, we just have to do one more thing, and that is to actually export the resolvers by writing export default resolvers. Access this into your schema.js file. So import resolvers from the resolvers file /resolvers.js. And so this gives us back the resolvers constant that we just declared. And to actually get GraphQL to use the resolvers that we just defined, pass it into your schema, like so. Let's rerun the app, or let's actually run the app for the first time in this lecture. File, save all. I'm not sure why we have an error. Let's see. Or you know what? Let me just press Control-C and try the build again. Cannot find module.resolver.js, and that is because I have an S right here. So let me just add that, and we should be good to go. File, save all. And we seem to be good to go. So let me just go to my Google Chrome, localhost 4000 /GraphQL. The site cannot be reached. Let's retry the build. Error query.author is defined in resolvers, but not in schema. And the reason for our error is because we're not properly referencing the query that we declared in the schema.js file. Make sure that these queries match so that when this query is called in GraphQL, we know to perform this query inside of our resolver. So let's try this again by saving all of our files, going back to our terminal, rerunning our build. Everything works fine, finally. If I go to GraphQL, the first thing I want to query is all of the authors. I want all of their ages. I want all of their names. I want all of their books. Let's run this. And there you go, J.K. Rowling, George R.R. Martin, and for some reason, the books are null. Let's investigate this. So in schema.js, books is capital. All right, so we just made a rookie mistake. So remember what I said before, type definitions specify exactly how information in the data store is modeled. We gave the user the option to query this field books, capital books. But this field is not present in our data store. Notice this is lowercase. So our resolvers were looking for this field of books, and it wasn't able to find it. It is not currently present in this array. However, this field is. So we should be good to go. If I save everything, go back to GraphQL, rerun this, cannot query field books on type author. And the reason why we still have an error is because in the type definitions, we specified a new field of lowercase books, not uppercase. So let's try this again. And we are good to go. It shows us all of our authors, all of their ages, names, and the books that they published. At the moment, however, this author resolve query takes no arguments. Its functionality is quite basic. We'll look to implement more complex queries in the next video. In the last video, we looked at how resolvers are able to perform queries and return the results of that query to GraphQL. In this video, we're going to make our queries a little more complex. Right now, all the query does is return every single author that's present in our data store. We don't have any functionality in which the user, or GraphQL in this case, has the option to be more selective in its query. That's what we're going to implement momentarily. For now, let's add some more fields to our data store. I'm going to copy and paste the following object. And instead of George R.R. Martin, I'm going to put Stephen King. I believe Stephen King is in his 60s, I'm not too sure. And one of the books he's written is The Green Mile, I believe, as well as Carrie, both of which are really good movies. And you know what? We'll stick to just having 3 objects for now in our data store. And one thing I want to fix is actually renaming this to authors. Since when we call this query, it gives us back every single author that's in our data store, it makes sense to have this as a plural. It's just more intuitive. And make sure to change it in the resolvers as well, since we're referencing the query that's inside of our schema. So that when this is called in GraphQL, we want it to be performed in the resolvers and return the list of authors back to the client. So enough of that. Back to our schema, we're going to specify a query that fetches only one author based on his age. You already know how to specify a query, and since the purpose of our query is only to give us back one author, call it author, and it's going to be a type of author. This query authors has an array type because it gives us back a list of authors, whereas this one is not an array type, as its purpose is going to be to only give us back one. And choosing the author is going to be based on his or her age. So add an argument, age, of type integer. Now we want to actually perform this query in the resolver when it's called by GraphQL. To do so, just like we did it before, in resolvers, add a comma right here, and we're going to specify a new query that is inside of our schema. This one, however, is going to have arguments. The first one is root, and the second one, args. Just like before, arrow function, and we're good to go. Do not worry about this argument. It's widely known for never being used. Args, however, is an object which is going to contain whatever arguments are passed into the query. If the query expects an age associated to the author we're trying to fetch, which it does, then the args object will contain the age that was passed into it as a property. In this case, we are passing an age into our query and we can access it through args. Let's just run this for now. File, save all. If I go to my terminal, I'm just going to clear everything. And I think I am inside of my GraphQL tutorial directory. I sure am. And if I just write npm run build, everything seems to be working fine. So I'm just going to navigate to localhost 4000/GraphQL. And suppose inside of GraphQL, we call this query right here author. And suppose inside of GraphQL, we call the query author. First, don't forget your curly braces since we're doing this inside of JSON format. And we're going to pass in an argument of 60, age of 60. And now back into the resolvers, we can access this age of 60 that was passed into GraphQL by simply writing const age is equal to args.age. Remember what I said before, this args object is going to contain whatever arguments are passed into the query. In this case, the arguments passed are the author's age, which is accessed right here. And we want to fetch the author with the age of 60. So what we would do is return authors, the array of authors, dot find. So basically what find does is that it's going to loop through the array until it finds an element with the age of 60. Once it does, as it says right here, it immediately returns that element value, and it's going to return it back to GraphQL. And as it's looping through every element of the array, we can access each element like so. You can call this whatever you want. Calling it author just seems more intuitive. And we want to check if that author's age, this element, matches the age that was passed into the query, this age right here. So simply return author.age, the element that's being looped through, his age, triple equal sign, the age that was passed into the query. If you're not familiar with the three equal signs, it's basically a Boolean check to see if these are indeed equal. If they are, it's going to return the element in which this is true, and it's going to pass him back into GraphQL. In this case, it's going to loop through each element until it finds one with an age of 60. As we specified here in GraphQL, it's going to return it to our client, and we should be good to go. Okay, let's try this out. Save all of your files. Your script should rerun. Indeed it did. So back into GraphQL. If I actually perform this query, we know it's going to give us Stephen King. So let's get his name. Let's get his age. And let's get his set of books. Perform the query. And perfect. We get back Stephen King, age 60, books, The Green Mile, and Carrie. Now back into here, we know that age is a property of an object. So we can actually directly access the age property like so. Specify curly braces since we know that it's inside of an object, and age. That is a lot cleaner in my opinion, and let's just test this out to see if it works. File, save all, rerun your query, and everything seems to be working out pretty fine. So, quick summary of what we have so far. We're making a request from GraphQL, which is handed over to GraphQL, or sorry, that request is passed into the express route / GraphQL. Express is going to hand over that request to GraphQL Express, and it's going to resolve this request to query right here in the resolvers. And in the resolvers, we're returning an author which matches the age that was specified in the query. And so finally, there is one more thing I should mention. Let's just assume that Stephen King and George R.R. Martin had the same age. Let's assume they were both 60. Rerun GraphQL. If I try this out, it gives us George R.R. Martin. Well, why not Stephen King? Well, remember what this does. It goes through every element of the array, and it gives us back the first one that it finds a match, and it returns it. The point I'm trying to make is age is something that can be duplicated. In your database, many of the users you have in there can have the same age. Many authors can have the same age as well, which is why querying for a single author is normally done with an ID, a unique ID. IDs are made to be unique. You'll see how once we implement a real database. For now, let's manually give each author here an ID. So this is going to have an ID of 21, an ID of 36 or 34. Stephen King will have an ID of 12. Make sure all of these IDs are unique since that's what you would have in a real database, unique UIDs. And make sure to declare these in the type definitions as well since they always have to reflect exactly what you have in your database. Or data store, fake data store for that matter. And the IDs that we declared were of type integer. Normally they're strings, but it doesn't matter. And now change the argument here to ID. We want to query based on an author's ID, not his age. And now back into our resolvers. We're not accessing the age anymore. We're accessing the ID that's given to us by the query. So make sure that we return the author's ID that matches the ID given to us by GraphQL. And back into GraphQL, make sure that we query an author based on his ID since age is not an option anymore. Run the query and we get null. The reason being we simply have to just refresh the page, try this again, and we still get null for whatever reason. Does anyone here have an ID of 60? Nope. But J.K. Rowling has an ID of 21, so let's try this out. There you go. We've successfully ran a selective query that grabs an author based on the ID that was specified by GraphQL. And that is it for this section. In the next one, we're going to do a bit more queries and finally look into some mutations. I will see you then. In the last section, we looked at very simple queries. You now know how to get GraphQL and Express to work together. There are two more components of this course that we need to master before we start our Twitter application, and that is how to work with databases and how to work with a React Apollo client. In this section, we'll cover databases with GraphQL. And that being said, we're going to work with mutations. We're going to write to our databases. And I don't know about you, but I am tired of using this hard-coded array as my data store. So let's actually set up our database called MongoDB. We're going to start by setting it up on OS X. So if you're using a Windows computer, I would skip ahead into this video until I get to the Windows part. And MongoDB is most easily installed on a Mac with the Brew package manager. To install Brew, make sure to go to brew.sh. In this website right here, it gives us a command that we can copy into our terminal in order to install Homebrew if you don't have it already installed. So press Command V to paste it, and press the return key, your computer password. We're good to go. Okay, so if you already had Brew installed before, make sure to update it by writing brew update. Obviously mine's already updated since I just installed it with you guys. And now, like I said before, we're going to install MongoDB using brew. So write brew install MongoDB. Now that we're done installing it, what I'm about to do now is very boilerplate stuff. It looks a little complex, but don't worry, you'll only ever have to do it once you get MongoDB up and running on your machine. You'll never have to do it again, unless of course you buy a new Mac and want to install Mongo onto that. So don't worry if what I'm about to do now looks a little complex. I'll walk you through it the best I can, but it's not very relevant to the course content since downloading Mongo is the same for whatever application you build. Anyway, any data that we save into MongoDB is going to be stored in the DB directory. This is where the Mongo data files are going to live. We can create this directory in a default location by putting make directory -p. And it's going to be a subdirectory of data. If for whatever reason it said permission denied right after you wrote this command, or if it ever says permission denied, make sure to put sudo right before your command to override the permissions. Now we need to ensure that Mongo runs in the background whenever our Mac is running. So make a new directory by writing mkdir-p. In this directory, launch agents will be inside of our libraries folder. Library/launch agents. Inside of this launch agents, we need to copy a file from MongoDB to ensure that MongoDB runs at all times. To copy this specific file, write cp, cp standing for copy. The file is a plist that we can access through /user/local/seller/MongoDB. And if you press tab again, your MongoDB version should show up. And now /homebrew.mxcl.mongodb.plist. This plist file has to be copied into our launch agents. So we're going to copy it there, /library/launch agents. There you go. And now we just need to launch this file that we just copied into launch agents. To do so, write launch ctl load -w, and we're going to navigate to the file that we just copied, library launch agents /homebrew.plist. Okay, now to see if everything worked out, write mongod. This should start the Mongo server, and it doesn't. It shuts down, and the reason is that it says that data/db, remember this is where all the data is going to be stored, apparently is a read-only directory. And so to defy the permissions that are being placed against us, we're going to recopy this command and write sudo right behind it. Write your password. And it's waiting for connections. Everything seems to be working out pretty fine. All right, now I know that we just did is a bit intimidating, but we didn't do anything special. All we did was run MongoDB in the background so that we can access it in the application. That's it. You'll never have to do this again since you've already done it once, and MongoDB will remain installed on your computer. And now this is just for installing MongoDB on the Mac. If you've already done this, you can skip ahead to the next video. If you are a Windows user, there is just one thing I need to point out, and that is that I don't actually have a Windows computer, nor have I had one in the past 4 years, but this is a great resource for installing MongoDB on Windows. To access this website into Google, simply just write install MongoDB on Windows, and it should be the first option that shows up. And if you scroll down, here are all the steps you need to get MongoDB up and running. Some of the steps are very similar to what we did with the Mac OS installation. such as setting up our /data/db directory, where the data from MongoDB is going to live. So unfortunately, I cannot actually record a tutorial on installing it for Windows, but I am going to attach some pretty good tutorials on how to install MongoDB on Windows in the resources folder of this lecture. Okay, so that concludes installing MongoDB. In the next video, we're going to link our application to MongoDB and write into our database. In this video, we're going to link our application to MongoDB and set up our model. First of all, we're going to install the node package mongoose into our project by going inside of our terminal. I'm just going to clear everything for now by first canceling this command or this action. Make sure you are in your project directory, and if you are, simply write npm install --save mongoose. Mongoose is simply going to make MongoDB much easier to work with and connect to. We're going to use it to query from our database and create some entries. And so once you have it installed, back into your server.js file, we're going to import the mongoose module. And through this variable mongoose, which inherits the exported properties and methods from this module, we're going to use it to connect to our database by writing mongoose.connect. And we have to connect it on a default port. That default port in which our database is going to run will be the local host. To run our database on the local host and connect it to our project, simply go to mongodb://localhost. And inside of our default port, inside of localhost, we're going to give it a path of GraphQL tutorial. This is where our MongoDB data store is going to live. This is where everything is going to be saved. And now to actually see if we successfully connected our application to a MongoDB database, all you have to do is write const connection is equal to mongoose.connection. And now we have to see if this connection is open. To do that, write connection.once. And if this connection is open, it's going to trigger a callback function. And if this callback function gets triggered, we're going to simply log connection to database was successful. So we're going to simply try this out by going on File, Save All. Back into your terminal, write npm run build to run the script. And connection to database is successful. We just connected our application to a database such that it's being run on localhost/GraphQL tutorial somewhere in our machine. Okay, now our database, or almost every NoSQL database you'll work with, needs a schema to describe how the data inside of it is going to be modeled. So we're going to create a new folder called models, and inside of it, create a file called authors, or author.js for that matter. And that's where we're going to create our author schema. So first of all, just import mongoose to actually use the mongoose module. Import mongoose from mongoose. And from it, we want the schema class to create our schema. So write const schema, and we're going to get this schema from mongoose.schema. Make sure it's capitalized to properly reference the class. And to define a schema, simply write const author schema is equal to a new schema. We want to create a new schema of author. And we're going to give it some options. And remember, every time we wanted to specify options or fields, they go inside these curly braces. This is nothing new. And so inside of here, we want to specify every author field. We have to make sure that this is exactly the same as how we defined our author type definition. Okay, this is how we want our data to be modeled. These are the fields that each author should have. Each one needs a name, an age, bucks, and an ID. Exactly the same as how, oh, I misspelled ID. And we want this to be modeled exactly the same as how we specified our type definition. Since the type definition here, it tells GraphQL how the data in our data store is modeled and how it's supposed to access it. It's the exact same scenario as what we had with the hard-coded array. The entries in the array had to be consistent with how we defined our type definition in order to keep things consistent. And since we're not using a hard-coded array anymore, it's the exact same concept with the database. The entries we save in our database, they need to be consistent with GraphQL's type definitions. Every author has to follow this schema such that it has a name, age, books, and an ID, just like here. Because imagine that we had an extra field here of, let's say, birthday. If you tried to query this birthday entry from GraphQL, obviously this is not something that's in our database, and it would just give you null, which would make things inconsistent. So the idea is the same, and before I proceed, I just want to reinforce that we're not actually using a hard-coded array anymore, so I'm just going to delete this and comment these out for now. We'll modify them very soon. So we're going to actually define our schema now, and every author will have a name of type string, an age of type number. The number type is the equivalent of our integer type right here. And it's going to have a type books. Of an array of string, we're going to have a collection of books and an ID. However, this ID is going to be auto-generated. What do I mean by this? Well, whenever we save an author inside of our database, we want MongoDB to auto-generate a unique ID for each author. How do we do this? Well, we're going to use a certain module called node-uuid. So we're going to import UUID, a unique UID, from node-uuid. And to actually use this module, we have to install it. So back into our terminal, I'm going to cancel this action by pressing on Control-C and write npm install --save node-uuid. And so whenever we save an author, an ID has to automatically be saved with a default value of type string and a default value of a unique UID provided to us by this module, uuid.v1. So what would happen is GraphQL would request some kind of mutation that we're going to specify here in the next video, but it would request a mutation with arguments age, name, and books. And the idea is that we want to save that specific author with age, name, and books, but we're going to auto-generate an ID such that it's unique to only that author. And there's just one more thing we have to do. This ID is of type string, and in the type definition, we're specifying an integer, which is wrong. We want it to properly model our data in the data store. So put this as a string, this as a string as well, and we should be good to go. And before I forget, I'm just going to remove this field. We don't actually need it. And that is all for schema definitions for Mongoose. We're going to start saving users into our model using GraphQL Mutations in the next video. See you then. Welcome back to another video. We finally set up our MongoDB database and wrote a schema, but haven't actually inserted anything into our database just yet. So in this video, we're going to look at mutations. And instead of requesting a query from GraphQL, we're going to request a mutation. That mutation request is going to be passed along over to GraphQL. But wait, what next? We haven't defined any mutation types yet. Remember, to perform queries, we have to define them in the type definition and access the query types in the resolvers in order to execute the requested query based on the data store. It's the same concept as queries, except in this case, we're going to define mutations and access the mutation type in the resolver and perform the mutation on our database, which doesn't actually have any entries just yet, but we'll work on that. And to define a mutation type, it's quite simple. Just like we defined type query, make a type mutation. And we're going to have a mutation to add a new author to our database. This mutation will be called add author, and it's going to take in arguments name, string, age of int, and books of an array of string. Remember, like I said before, all we're going to pass in to save a new author is name, age, and books. However, the ID is auto-generated by MongoDB itself, so we don't actually have to pass it in. And so the user has to put in these arguments, and just like we referenced queries in the resolvers, now we're going to reference the mutation. So in your resolvers.js file, there's something I forgot to do, and that is to make this of type author, since we're mutating an author type. And so let's actually reference our mutations now. So inside of resolvers, similar to how we referenced queries, we're going to reference mutation. And the mutation that we want to access, that we want to perform, is this one right here, which will be requested by GraphQL. So add author is going to have argument types root, as well as the arguments placed in by GraphQL, which are simply age, name, and books. So name, my computer froze for a second, name, age, and books. And given these values, we want to save our author right here. To save something in MongoDB, first we're going to import Mongoose. So import Mongoose from the Mongoose module that we installed previously. And we need to save our author based on this model, on this schema. So we have to actually export this model first and foremost. Export default model and import it in schema.js, or resolvers.js, I should say. So import author model from this file right here. So first navigate to your models folder /author.js. Perfect. And now to save the author based on the arguments provided to us by GraphQL, simply write const author is equal to author model, or new author model, since it's a new author that we're saving. And remember that the author model, it had fields of age, name, and books that we're going to save. And so the age that we save for the author is simply the age provided to us by GraphQL. The same thing for the name and for the books. All right. And to actually save this author into our database, all we have to do is write author.save. And you know what? We want to actually return the results of that save back to GraphQL. So let's just write return. And we're done. This is exciting. We're going to request this mutation from GraphQL. It's going to be passed over to our express endpoint /GraphQL. It will hand over that mutation request to GraphQL, which is going to resolve that mutation in the resolvers by grabbing all of the arguments that were passed into by GraphQL, and it's going to save a new author based on these arguments and save him. It's going to save him and return the results of that save. Let's test it all out. So file, save all. And if I just go to my terminal, make sure there are no errors. Error, query type defined in resolvers, but not in schema. And it looks like one of the files wasn't saved before I ran it, but everything seems to be working out now. So if I just go to GraphQL, I'm going to delete this. You can ignore that. It's from another lecture. I'm going to refresh GraphQL, and to specify a mutation, first write mutation and open up curly braces. And the mutation that we want to specify is add author. And add author takes a name. We're going to give the author a name of Stephen King, an age of 65, and books of carry and the green mile. And if the save is successful, give us back the name of the author we just saved, which will simply be Stephen King. Give us back his age, give us back his books. So just give us back all of that information if the save is successful. Otherwise, we'll just get an error message right here. And so run this, and everything seems to have worked out pretty fine. We just saved our first entry into an actual database using GraphQL. But now how do we actually see the entries in our database? You could do it using the terminal, but I'm not a big fan of that. There's a great tool called RoboMongo. Well, now it's called Robo3T. But if you simply just go to Google and write RoboMongo, I'm going to go on RoboMongo Mac for now, since that gave me a nice link. So if you click on the first link, it's not just for Mac. You can actually download it for both Windows and Mac. The download for this is very simple. It's a one-step process. You press download, it asks you to put in your name or email or something, and that's it. So once you do that, you should have this software right here, Robo3T, which I'm going to open. And since this is not my first time opening it, it already created a new connection for me. I'm going to delete it and pretend like I'm in your shoes. So I'm going to remove this, create a new connection where our database is being run on localhost. Remember that we're running our database on localhost such that it's connected to our application on this specific path. So we can actually go to this path right here, GraphQL tutorial. That's where our data is being saved. And if I go to collections, authors, and right here is the document we just saved inside of GraphQL, Stephen King. This is perfect. Here's his age. Here's the auto-generated ID and the books. Now what happens if I go back to GraphQL and I simply don't save any books, and instead of Stephen King, let's just say I put William Shakespeare. So if I save William Shakespeare, everything works out correctly, but it saves an empty array of books and gives it back to us. So if I go back to GraphQL, or RoboMongo for that matter, it saves an empty array of books along with the name, age, and ID. That's odd. I'm pretty sure for someone to be an author, they have to have some books published, right? Or some kind of play. It doesn't make any sense otherwise. And so this field needs to be mandatory. And at the same time, every author needs a name as well. This also needs to be a mandatory field. Well, we can do just that. So the user must put in a set of books, and he must put in a name into GraphQL. Otherwise, we want to throw an error. Let's try it out. Back into schema.js, add an exclamation mark after each field. So you're making these mandatory fields. If one of these fields is not present in GraphQL, make sure to throw an error. It cannot be null. So I'm just going to put file save all into my terminal and back into GraphQL. What if I tried to leave out the field of books? It throws an error. But if I put it back and specify some books, let's actually change this to J.K. Rowling, age 50 something, and books, Harry Potter 1, Harry Potter 2. And so if I actually put books in, everything works out fine since this is a mandatory field. Well, actually every field is mandatory in this case since we put an exclamation mark after each one. So if I try to remove age and try and run this, it gives us an error again. And that is it for this video. In the next one, you're going to learn how to delete and edit entries from our database using mutations. In this video, you'll learn how to delete and update authors from our database. Simply enough, this is also a mutation that once again, we have to define in our schema.js file. The mutation will simply be called, as you've guessed it, delete author. And we're going to delete an author. And based on the ID provided by GraphQL, we're going to delete the author associated with that ID. So write ID string, that's what we're going to pass into from GraphQL, and make sure that the ID is mandatory. And of type author, since we're deleting an author type. As always, we're going to reference this mutation inside of resolvers, so that once again, once it's called inside of GraphQL, resolvers can actually perform this mutation. So the mutation we're referencing is delete author that we just specified. It's going to have the argument of root and the fields that are being passed into from GraphQL, which is simply the ID. Upon accessing that field, we want to delete the author associated with this ID. Forgot my comma. So simply write author model, and we will remove the author based on the ID provided. So author model.remove, and we'll remove the document from the collection which has ID equal to the ID provided to us by GraphQL. And we're going to return the author that was just removed. Let's save all of our files and test this out. If I go to my terminal, I have an error for whatever reason. I'm going to cancel the command, save all of my files again. Try npm run build. And everything seems to be working out fine. And now, before I actually do anything else, you should notice this deprecation warning. This warning is actually quite harmless. It doesn't do anything. But if it really bothers you, there's a workaround to fixing it by simply adding a use Mongo client option into our connect function. But you know what? We'll just add anyway. So add the use Mongo client, true. Now this doesn't actually do anything. It's just there to get rid of this annoying warning. And so if I save all of my files and try this again, the warning is gone. Like I said, this is totally useless. Don't even worry about it. It was just there to get rid of the warning. And so the initial goal was to actually go to GraphQL and test out our delete mutation. And if I just refresh this, we're not going to add an author now. We're going to delete one. And we have to delete the author associated with a specific ID. And the author that I want to delete is this one right here, Stephen King, with books, with this specific ID. So to actually copy this ID, simply view the document, copy and paste it right onto GraphQL. And upon removing this author, I want the name of the author that we just removed. Notice that it gives us back null, but if I go back to RoboMongo and actually refresh this, notice that it removed Stephen King. He is nowhere to be seen. So what happened was that we requested a mutation from GraphQL with a specific ID. That mutation was passed over to Express, which handed that mutation to GraphQL. It was resolved in the resolvers such that we removed this author based on the ID specified by GraphQL, and it removed the author accordingly. But it returned null, and that's because instead of calling remove, we're supposed to call find one and remove. So it's going to find that author, return him, and then remove him from our database. So if I go on File, Save All, try this out again, and it gives us back null, which makes sense because we already removed the author with that ID. He is nowhere to be seen in the database. So let's try and remove William Shakespeare, who has this ID right here. Copy and paste this right onto GraphQL. Run it. And it found the author, William Shakespeare, and deleted him. Let's see if it actually deleted him by refreshing RoboMongo, and he is gone. Now what if I asked you to update a user? I'm going to let you figure out the first two steps to this. Pause the video and give it a try. Okay, so like always, we have to define another mutation type. The mutation type is update author with an ID string. This one is going to be mandatory. For the user to update an author, he has to put in an ID, otherwise throw an error. And so we're going to find the user with a certain ID and update his name, for example. So make sure to pass in an argument, name, as well. This will also be mandatory. This mutation is obviously of type author. And now make sure to reference this mutation inside the resolvers. The mutation that we just defined was update author. It's going to have arguments root, as well as the parameters that are being passed into from GraphQL, which are ID and name. So we're just going to access them directly right here. ID, name, and right here in this callback is where we are going to, forgot my comma. And so right here is where we are going to actually return the author that we just updated. And to update an author, write author model dot find one and update. This first field right here is where we're going to specify which author we want to update. We want to update the author based on the ID that was given to us by GraphQL. And that author that we just found, we want to update his name. And we will update his name based on what was given to us by GraphQL. And that's it. That is all. So if I go to File, Save All, everything should work out fine. Let's check our terminal. We get an error for whatever reason, but if I try and run this again, we should be good to go. And we are. And the author we want to update is this one right here, J.K. Rowling, which has this specific ID. So if I copy this right onto GraphQL, well, first let's actually define our mutation right here by first refreshing the page and write update author. The ID of the author that we want to update is this one. And we're going to change the author's name to George R.R. Martin. And that author that we just updated, give us back her name. Run this. So we just updated the author J.K. Rowling, and we changed her name to George R.R. Martin. This worked very well. Now there's one more thing we have to do. We removed the logic for our queries because they were fetching stuff from the hard-coded array. We're going to fetch documents from our database. And if you remember, this query has the purpose of fetching every single author inside of our documents. Right now we only have one. Let's at least have two by calling add author. We're going to add a new author with name J.K. Rowling, age 50, and books Harry Potter 1 and Harry Potter 2. Let's add J.K. Rowling. We get an error. Oh, this should be an integer, not a string. I don't know why I did that. Go back to RoboMongo. Here's J.K. Rowling. And right here in this query, we want to access all of these authors, all two of these authors. To do so, simply write author model dot find, and we want every single author. We don't want any limitations on which author we want. Just give us back everything in the database, so don't specify any fields here. So if I just press on File, Save All, go back to my terminal, everything works fine. And if I call this, and instead of mutations, we're going to perform some queries. The query we want to perform is authors, and give me back every author's name, ID, and age, and books that's inside of our database. And we get null, of course, because I forgot to return this, so it did not return any results back to GraphQL. File, save all. Try this again. Type error, failed to fetch. Let's rerun our build. And we're good to go. It fetches everything back. Now, what if I added one more author into our database? So I'm going to call a mutation of add author, and that author is going to have a name, Stephen King. He is going to have an age of, let's give him the same age as someone in our database. Let's give him an age of 65. With books, Carrie, and The Green Mile. Just going to add that author. And I made the same mistake again of making this a string. It should not be a string, it's an integer. Run this, and we have another author with age of 65. Now what if, instead of querying every single author, I want only the authors with age 65? Well, what I would do is place some limitations on this. So I'm going to find every single author with the age provided to us by GraphQL. And so to actually do this, we need to go back into our schema.js file and give this author's query some arguments, or just one argument of age, which is of type integer. And back into resolvers, we actually have arguments for this of root and the age that we're passing in from GraphQL. And if I go on File, Save All, refresh this, we get an error for whatever reason. If I go back to my terminal and rerun our build, let's see what's going on. Everything seems to be working out fine. So if I rerun this, authors, which takes in an age, and we want to query only the authors with age of 65. So put 65 and return these authors as name. Let's try it out. It gives us back George R. R. Martin and Stephen King, and it leaves out J.K. Rowling. So you just learned how to selectively query a list of authors. And now finally, we're going to fix this query as well. And remember, this query had the purpose of finding a single author based on his ID. So return author model.findOne, since we're only finding a single author. And we're going to find that author based on the ID provided to us by GraphQL. So if I go on File, Save All, everything is successful. Back to GraphQL. Going to call the author query, which takes in an ID. And the author that I want to fetch is J.K. Rowling. View document. Copy this right onto GraphQL. And we want the author's name. And there you go, we fixed our query. That is all for mutations and queries through GraphQL to an actual database. So you just learned how to work with Express, GraphQL, and perform queries and mutations on an actual database. The only missing component of the course before we start moving on to making our Twitter application is how to set up a React Apollo client. Right now we're using the GraphQL query editor to mutate and make query requests, but we want to make these requests from an actual client which actually modifies the user interface of this page according to how we want our application